Good afternoon, Kip. This is Mr. Navarro. Welcome back to 7th grade science. Today we're continuing on with our population resources unit. Today we'll be looking at lesson 2.3, births in a changing population. So let's get started. You know that organisms need energy from energy storage molecules to reproduce, and that they get energy storage molecules by eating organisms from other resource populations. How will a change to a resource population affect its consumer population? In this lesson, you will use the sim to investigate this question. At this point, I'd like to let you know that you may log into your Amplify account and through Clever and use this sim as we go along on the video or do it on your own. However, for those of you who do not have access to Amplify, this video will take you through all of the same steps that you would be asked to do if we were in class and you were in front of your own laptop. So to get started, on the Google Classroom page, there will be this link for the Young Fox Hunting in the Snow video. I'd like you to watch that before we begin our PDN, so please go ahead and pause this video now, watch the YouTube link, and then come back in about 3 minutes. Now that we're moving on, it's time for your PDN. So, small animals called voles are found in the same ecosystem as red foxes. The diagram above is called a food web. It shows the relationship between foxes and voles. What does this food web show? What do you think the arrow tells you about energy storage molecules? Now, these questions will need to be answered on today's Google form, and that can be found in my Google Classroom. It will be labeled PR 2.3 Guided Notes Google Form. The aim for today again, you can pause this video and fill out your forms as we go, but our aim for today is to explain how the size of a resource population affects the number of births in a consumer population. In today's activity, we are going to watch how this food web actually works. So, the title of this activity is Energy Storage Molecules in Ecosystems. Organisms get energy storage molecules to reproduce from the resource populations that they eat. Today, you will investigate the wee bug population in the sim. First, you need to figure out where the wee bugs get the energy storage molecules they need to reproduce. So in order to do that, you can log into Amplify, go to lesson unit, Populations and Resources, Chapter 2, Lesson 3, and you can follow along on your own. If you are unable to do so or don't wish to, just stay with me on the video and walk you through it. So our first step will be to launch the Populations and Resource Simulation, observe the wee bugs, and look for the food web overlay, and then answer the following questions on the Google document. So let's go ahead and do that. As you can see, I am on 7th grade Amplify Science. I will find the Populations and Resources unit. I'll go to Chapter 2 and Lesson 2.3. The simulation is in Part 2 of the activity. So, the exact instructions are to open the simulator. You do so by clicking on the blue link and use the 3-population mode. So let's get started. All right, here we are. So we're now logging into the 3 populations mode, so it's the middle option. And our instructions were to observe the wee bugs. Also make sure that we observe the food web overlay. So we will zoom in on a wee bug. And notice how its storage of its energy or its food storage molecules increases and decreases as it does activity. As it's eating, its storage goes up, it fills its tank. When it's expending energy, its levels drop or decrease, and it needs to go find a green leaf to replenish its molecules. So at this time, answer the following questions. How are the energy storage molecules represented in different parts of the sim? Where are the energy storage molecules found in an ecosystem? Where do the wee bugs get energy storage molecules in the sim ecosystem? And what is your evidence for that? I'll let you answer those questions on your Google document, and you can continue watching the simulation. Okay. The next part of the simulation, changing the number of births in a population. What can change the number of births in a population? We're going to use the sim to find out. In the sim, wee bugs eat green leaves. So you can watch your food web go from the energy storage molecules in the green leaves being consumed, energy being transferred to the wee bugs. So wee bugs get energy storage molecules from eating green leaves. What change to the green leaf population could increase the number of births in the wee bug population? Pick one. You can do this in your Google document as we go along. Now, review these steps below. What will you change the independent variable in the test? So which of these are you going to wish to see? Are you going to want to increase green leaves or decrease green leaves? What will be observed and recorded, the dependent variable? And what will be kept the same to control, or the control in the test? In order to do this, we're going to follow the instructions on Amplify. So we'll go back. Our sim will be changing the number of births in the sim. Now, we obviously know that we can increase the food supply of the wee bug, will actually increase the amount of energy that wee bugs have to move around, to reproduce, and hopefully increase their population. So what we're going to do today is increase the green leaf population. So what we're going to change is the green leaf resource population. That will be the independent variable that we are testing. What we will observe and record will be the wee bug consumer population, meaning will we see a rise in the number of wee bugs on the simulation. And what will be kept the same, or what are we not messing with? We're not messing with the furble consumer population. The furbles are the things that eat the wee bugs. So in order to do this, we're going to launch our simulation. We're going to hit play and run that sim for 20 time units and then hit pause. Then we're going to open the food web overlay. We will then make the changes to the greenleaf population that we predicted would increase the number of births in the wee bug population, meaning we're going to increase the greenleaf population, and then we're going to observe the number of energy storage molecules in the greenleaf population changes as you make that change. So we're going to make a big change to see the biggest effect. Then we're going to lock that greenleaf population, press play and run it for 20 more units, and then analyze and compare between those two results. So let's get started. So once again, we're going to pick our 3 population. We're going to zoom in. We are going to hit, reset time. And then we're going to hit run. Counting up to 20, and then pause. So once we've hit that, we're going to open up the food web overlay view. And we'll make a note that our greenleaf population is 116. Our wee bug population is 114, and our furball population is 37. So our next step will be we're going to increase this number of wee bugs. Correction, we're going to increase this number of greenleafs dramatically. I'm going to max it out, and then I'm going to lock that population. So that's going to stay at a very high rate. Now, what we're going to do is run this simulation for 20 more seconds and observe what happens to the wee bug population. And there we go. That's another 20 seconds. So what did you observe? Did the wee bug population increase due to us changing the population of the greenleafs? Go ahead and record your findings in your Google form now. So here is what you would put your number for, your number of births, and then we would have our number here after we've done the change. So after you've run this experiment and observed it a couple of times, go ahead and answer the following questions on your Google form. So after the change, after the change, there were more births than deaths, fewer births than deaths, the same number of births than deaths in the wee bug population. After the change, the wee bug population increased, decreased, or stayed the same. Then you'll need to fill in the blanks on the following set of 3 sentences using the drop-down menu that I've provided on your Google form. And the last question Given the results from above, what change do you think would decrease the number of births in the wee bug population if we increase the green leaves or decrease the green leaves? And tell me which one you chose and why. Go ahead and pause the video, and you can do so now. Lastly, our key concepts. The larger the resource population, the more energy storage molecules are available for its consumer populations. I hope this video has helped you understand the relationship between resource populations and consumer populations in relationship to their ability to increase a birth rate. If you have any questions, please reach out to me. Other than that, tomorrow we'll have one more lesson in Chapter 2. It'll be Lesson 4. And then Friday we will be having our review quiz for Chapters 1 and 2. Once again, feel free to reach out to me, message me via Google Classroom. Other than that, I hope you all have a nice day. Don't work too hard, and I will see you tomorrow.